This is the notes for section 8.6, Pythagorean theorem. And this whole lesson is about the Pythagorean theorem, not only what it is, but how to use it. So first of all, let's define the Pythagorean theorem. It's one of the oldest, most famous, and most used theorems in math. And it just says in any right triangle, so we're dealing first of all with the right triangles like I have drawn here, with legs of length A and B, and I have hypotenuse of length C. And remember, the hypotenuse is going to always be opposite the right angle. So if this is my right angle here, then C, the hypotenuse, has to be opposite it. Then Pythagorean theorem says that if I square the two legs and add them together, a squared plus b squared, it will always be equal to the square of the hypotenuse. Okay. Now, there's a kind of an alternative way of looking at that, and that's looking at it from the standpoint of what the square of the legs are and what the square of the hypotenuse is. And if we look at it from those areas of those things, so it says in a right triangle the sum of the areas of the squares on its legs equals the areas of the squares of the hypotenuse. So this square, a squared, and this squared, b squared, if I take all of this area and all of this area, it will fill all of this area for areas of the leg C, the square off of leg C. Okay, in your book they go through a formal proof of Pythagorean theorem. I want to take a little bit of different approach here. I want to look at it kind of strictly from a geometric standpoint, and looking at the areas of the squares A, B, and C. So what I've done is I've taken our right triangle ABC with legs A and B and hypotenuse C, and I've created a square, a bigger square, with the triangles. So I've got 4 triangles put together, and by doing that, the dimensions of my bigger square is A plus B. Okay. And the dimensions of my smaller square is this is A plus B on each side, and this smaller square is C on each side. So what I want to do is I want to show that the area of this square C is equal to the area of A squared plus B squared. Okay, and I'm going to do it over here in this picture by moving the triangles around to show you that is the case. So I'm going to move these triangles around, and remember now the red area represents the area of C squared. Okay, so if I do that, if I move these triangles around a little bit, okay, and as I'm doing that, you can see that they're going to fit. So now if you look at what's left over here, the red now, this red area, which still represents C squared, okay, that as I look at that, there's 2 squares there. This square, okay, which is B by B, so this is B squared, and then I have another square down here which is A by A, therefore that is A squared. So the red area, which was originally C squared, is now equal to A squared plus B squared. Okay, let's look at example 1 here. It says a soccer player kicks a ball east for a distance between 50 and 65 yards. Then the player kicks another soccer ball south for a distance between 40 and 50 yards. What is the range for the distances between the two balls? Well, what I'm going to do is I'm going to make 2 triangles to go ahead and solve this. The first one is going to be kind of the minimum distances that he could have kicked it, and the second one will have the maximum distances that he could have kicked the ball. So on this first triangle, I'm going to label that he kicked it 50 yards east. So I'm going to put this distance right here on this side as being 50. And then I'm also going to go, I'm sorry, yeah, we'll make this the minimum one. So if this is 50, then he kicked it south 40. Okay, so we're trying to find, so here's where one ball is, and here's where the other ball is. So I want to find what this distance is. Now I'm going to do the same thing for my maximum distances. So this would be 65 going east and 50 going south. So here's ball 1, here's ball 2. I want to find this distance here. So I need to use Pythagorean's theorem to solve both of those. So I'm going to lay out this by just taking the legs and squaring them and adding them together. 40 squared plus 50 squared equals x squared. That will give me my minimum here. This is for the minimum. And then over here I'm going to say 50 squared plus 65 squared is equal to x squared. And that's going to give me my maximum. Okay? So what we want to do to solve those, now to get x by itself, what I need to do is take the square root of it. Okay? So what that means is I need to take the square root of 40 squared plus 50 squared to find what that minimum distance would be. The same thing would apply over here. I take the square root of both sides here. This is going to give me x. Now I have the square root of 50 squared plus 65 squared. So I need to do both of those on my calculator to come up with my answer on that. And if I do that on my calculator, I come up with an answer of about 64. So the minimum is approximately 64 yards. Should put that yards in there. And the maximum would be taking the square root of 50 squared plus 65 squared, which I'm going to do on my calculator as well. So that's approximately 82. Now make sure you try both of these on your calculator and make sure you're able to get those answers. If you're not getting those answers, you're probably doing something wrong with your keystrokes with your calculator, and let's talk about that in class to make sure that we're doing that part correctly. So we know if we have a right triangle, a squared plus b squared equals c squared. Well, what if we have a squared plus b squared equals c squared? Does that give us a right triangle? Well, the converse to the Pythagorean theorem says yes, that's true. So anytime I know that if I have three numbers and I'm trying to figure if those three numbers would be side lengths of a right triangle, if I take the two shorter ones and square them and add them up, so the a squared and the b squared, add them up and see if they equal the longer side. If they do, then I know I have a right triangle. Now, if when I take a squared plus b squared and c squared is greater than that, then I know my triangle is obtuse. And if c squared is less than a squared plus b squared, then I know it's acute. So here's example 2 now. It says a set of three whole numbers that can be the lengths of the sides of a right triangle is called a Pythagorean triple. Okay? Decide if 15, 18, and 23 is a Pythagorean triple. If not, decide whether the triangle with those side lengths would be acute or obtuse. Well, the way that we do that is we plug this into the Pythagorean theorem and see what happens. If it's equal, then we know that it's going to be a right triangle. If c squared is greater than a squared plus b squared, then we know it's obtuse. If c squared is less than a squared plus b squared, then we know it's acute. So let's go ahead and do that. So I'm going to just say 15 squared plus 18 squared, and we want to see what it is as it compares to 23 squared. Okay? So that's what we want to do, and we want to get our calculator out to do that, and let's see what we get here. 15 squared plus 18 squared is 549. And 23 squared is 529. Now, 549 is not equal to 529, so we know it's not a right triangle. We know that c squared is less than a squared plus b squared, which if c squared is less than a squared plus b squared, kind of like what we have here, that tells us that our triangle must be acute. So for number 2 here, the answer is acute. So we can use the Pythagorean theorem to not just find the length of the hypotenuse, but we can use it to find the length of any side of a right triangle. So I have 3 different examples here, 2 of them finding a leg of the right triangle, and the third one we're finding the hypotenuse, or the C value for that right triangle. So you're still going to use the same formula, but you're going to solve a little differently depending on which one you're trying to find. So if I'm looking at this first example, I'm going to set it up again using a squared plus b squared equals c squared, because we know that that relationship is true. So I'm going to say 8 squared plus b squared is equal to 17 squared, because we know that 17 represents the hypotenuse there. Okay. On this one over here, and we'll solve that in a little bit, on this one over here I'm going to set it up as a squared plus b squared equals c squared as well. So I'm going to say 4 squared plus b squared is equal to 20 squared, because in that one 20 is your hypotenuse. And in this last one, I'm also going to use that relationship, a squared plus b squared equals c squared, but this time I'm going to put in the 2 5's for a and b, because we don't know the hypotenuse. There's c. So I'm going to say 5 squared plus 5 squared is equal to c squared. So the first one I'm going to do is the easier one, where I'm just solving for c. To do that, all I have to do is simplify this left-hand side and then take the square root of it. Well, 5 squared plus 5 squared, that's 25 plus 25. That's equal to c squared, which is equal to 50. So c squared is equal to 50, and then if I want to find c, I just need to take the square root of it. Okay. Well, the square root of 50 is, so if I'm going to find this exactly, and you can do that on your calculator there, the exact value, if you just punch that in on your calculator and hit enter, it's going to give you 5 times the square root of 2. That would be the exact value for that. Okay. Now we can get a decimal approximation to that as well, but let's just leave it as the exact value for right now. So that's what we would have for that one. For those of you who don't remember from last year how we get to this, remember 50 is the square root of 50 is the same as the square root of 25 times the square root of 2. And the square root of 25 times the square root of 2, well, the square root of 25, that's where we get the 5 from, and then the square root of 2 stays there. Okay? Alright, so if I'm going to solve a here now, I would have to subtract 8 squared from both sides to solve for b. If I do that, I have b squared is equal to 17 squared minus 8 squared. And notice I haven't used my calculator at all yet. And then I'm going to take the square root of both sides. So b is actually equal to the square root of 17 squared minus 8 squared, which if I do on my calculator is 15. So the answer for that length of that side is 15. Now what that means is that 8, 15, and 17 are a Pythagorean triple. Okay. The last one, if I'm going to solve that one, I'm going to do the same thing. I'm going to subtract 4 squared from both sides, which leaves me b squared is equal to 20 squared minus 4 squared. And then I'm going to take the square root of that to find b. If I plug that one into my calculator, I come up with 8 times the square root of 6, which is also approximately 19.6.